Okay, starting off with rates of reaction. Rate of reaction क्या होता है? We can also call it the speed of a reaction. How fast a reaction is, ठीक है? What is the speed of a reaction? How fast the reaction is taking place in a particular time period. So how can we measure rates? Remember, देखो, a reaction always proceeds from reactants to products. Now there are two ways that you can measure the rate of a reaction. Either you can see that how much reactant has been used, or you can check that how much product has been formed, because that is what happens in a reaction. Reactants are converted into product. So you can measure either the reactants used or the products produced. Any one of these would give you what is the rate of reaction. You should be able to describe experiments to investigate the effect of surface area, concentration, temperature, and a catalyst on the rate of reaction. For example, सबसे पहले हम surface area का देखेंगे. We know that more the surface area, faster would be the rate of reaction. So step number one, set up the equipment as it is shown in the diagram below. You can see a conical flask and we have dilute hydrochloric acid. अब ये dilute hydrochloric acid है, we have a conical flask. This is where it's going to all condense और यहाँ पे वो form हो जाएगा in water. Now we're going to add calcium carbonate chips to the hydrochloric acid after a fixed time and record the volume of the water displaced. Now we are going to record the volume of water that will be displaced. अब जैसे मैंने calcium carbonate डाल दी HCl में, there is a reaction taking place between calcium carbonate and hydrochloric acid. And what are the products going to be? When a metal carbonate reacts with an acid, you have a salt plus carbon dioxide plus water. Now, within among the products, we have carbon dioxide whose bubbles you can see over here. The bubbles of carbon dioxide are being produced over here that you can see. So this is what you can actually measure which the gas is collecting. Repeat using different forms of calcium carbonate. You can use a powdered calcium carbonate as well. You can use the chips of calcium carbonate, whole lumps of calcium carbonate as well, and then see. जैसे कि if you take a lump form of calcium carbonate which have a lesser surface area, they would produce less number of bubbles. मतलब कि less CO2 would produced. If you take powdered calcium carbonate, now powdered calcium carbonate का क्या मतलब है? That the surface area of powdered calcium carbonate would be higher. Hence, more CO2 bubbles can be seen, which means that faster was the rate of reaction. So add dilute hydrochloric acid to the conical flask. Use a delivery tube to connect this flask to an inverting measuring cylinder. Add calcium carbonate chips into the conical flask and close the bung. Measure the volume of gas produced in a fixed time using the measuring cylinder and repeat the experiment with different sizes of calcium carbonate chips. अगर मैं effect of concentration देखूं, we know that higher the concentration of reactants, faster would be the rate of reaction. So now we're going to add acid to sodium thiosulfate solution and start the timer. अब मैंने क्या किया हुआ है? Beneath the conical flask, I have a paper with a cross on it. Inside, I have a solution of sodium thiosulfate और ऊपर से मैं क्या डालूंगा? I am going to add some acid. The moment I add the acid, I am going to start my stopwatch. I'm going to start my stopwatch and I'm going to note down the time until it takes the cross to disappear. आहिस्ता आहिस्ता क्या होगा? The solution is going to become cloudy. वो जो solution है वो आहिस्ता आहिस्ता cloudy होता जाएगा, इतना cloudy उस तब तक मैं स्टॉप वॉच चलाता रहूंगा जब तक वो पूरा मिक्सचर क्लाउडी नहीं हो जाता. और वो नीचे से देखो, अब वो क्रॉस डिसअपेयर हो गया. जैसे क्रॉस डिसअपेयर हो जाएगा, आई एम गोइंग टू stop the stopwatch. That is the point where I'm going to stop the stopwatch and measure the rate of reaction. Stop the timer when X is no longer visible. जैसे देखो, mixture has become so cloudy that this is the point where you have to stop the time. Note the time it takes. अब आप different concentrations use करो. 1 mole per dm cube, 2 mole per dm cube, 3 mole per dm cube, 4 and 5 mole per dm cube. The more the concentrated the solution gets, the lesser the time it would take, and lesser the time means faster would be the rate of reaction. More the concentration, lesser the time will it take for the cross to disappear, higher the rate of reaction. So first of all, measure 50 centimeter cube of sodium thiosulfate solution into a flask. Then measure 5 centimeter cube of dilute hydrochloric acid into a measuring cylinder. Draw a cross on a piece of paper and put it underneath the flask. Add the acid into the flask and immediately start the stopwatch. Look down at the cross from above and stop the stopwatch when the cross can no longer be seen. Repeat using different concentrations of sodium thiosulfate solution and mix different volumes of sodium thiosulfate solution in the water to dilute it. The result would be that there will be an increase in the concentration of solution or rate of reaction increase हो जाएगा. क्यों? Why does increasing concentration increase the rate? Because when you increase concentration of a solution, there would be more reactant particles. जब ज़्यादा reactant particles होंगे, they are going to collide more often. And when they collide more often, the rate of reaction would also increase. Now let's check the effect of temperature on the rate of reaction. Heating dilute hydrochloric acid to a desired temperature, adding a strip of magnesium and then starting top. अब मैंने इस HCl solution को heat किया and then I have added a strip of magnesium in this HCl. Now I am going to start the stopwatch and I am going to stop the stopwatch until the magnesium strip has completely dissolved. I can repeat this experiment at different temperatures. Let's say 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius and 40 degrees Celsius. In a 10 degrees Celsius temperature solution, it let's say जो in a 10 degrees Celsius temperature, the time it took for the magnesium ribbon to disappear was 11 seconds. Then at a higher temperature, it took 9 seconds. At 30 degrees Celsius, it took 5 seconds. And at a 40 degrees Celsius, it took almost 2.5 seconds. So you can see as you are increasing the temperature, the magnesium ribbon starts to dissolve even faster. Time decrease hota ja raha hai. Lesser the time for the reaction. Reaction is taking less time, which means the rate of reaction is getting higher. So dilute hydrochloric acid is heated to a set temperature using a water bath. Add the dilute hydrochloric acid into a conical flask, add a strip of magnesium and then start the stopwatch. Stop the time when the magnesium fully dissolves and repeat the experiment at different temperatures so you can, compare the results as well. The result would be that with an increase in the temperature, the rate of the reaction will increase, and this is because the particles will have more kinetic energy than the required activation energy. Therefore, more frequent and successful collisions will occur, and that would increase the rate of reaction. A fourth factor after concentration, surface area, and temperature, we have the effect of catalyst on the rate of reaction as well. What is a catalyst? Catalyst is something that speeds up the reaction. So here you can take hydrogen peroxide solution. And what am I going to do? Hydrogen peroxide solution and a chosen catalyst. मैंने इसके अंदर एक catalyst भी add कर दिया है. ठीक है. I have added a catalyst and I have seen the volume of oxygen being produced. मैंने क्या देखा? What is the volume of oxygen being produced? That can be seen from the bubbles as well. So add hydrogen peroxide into a conical flask. Use a delivery tube to connect this flask to a measuring cylinder. Add the catalyst manganese oxide into the conical flask. Measure the volume of gas produced and repeat the experiment without the catalyst. Let's say with catalyst, it took with the catalyst 50 centimeter cube of oxygen gas was produced. But without the catalyst, when I carried out the experiment, let's say 29 centimeter cube of oxygen was produced in a certain time, which means that without the catalyst, the rate of reaction was slower. It only produced 29 centimeter cube of gas. But with the catalyst, the reaction was faster as it produced 50 centimeter cube of oxygen. So there are several factors that can affect the rate of reaction that we have studied from the practicals as well. Concentration, temperature, surface area, and the use of catalyst. Changes in these factors directly influence the rate of a reaction, and it is of the economic interest to have a higher rate of reaction. Everybody wants that their reaction rate should be higher, as this also implies a higher rate of production and hence a more efficient and sustainable process. अब आप देखो, there's a difference in the graph as well. This is a graph of a lower concentration. This is a graph of a higher concentration. It has more gradient. आप ये देखो, the graph is steeper. ठीक है, उसका जो gradient है, the gradient is steeper. It has more slope. Higher gradient है, मतलब कि faster was the rate of reaction when the concentration was higher as well. Compared to a reaction with a reactant at a lower concentration, the graph line for the same reaction, but it was higher, had a steeper gradient at the start and then at the end horizontal हो जाती है. देखो, amount of products is the same. ठीक है, Low concentration also produced 100 products. The green concentration also produced 100 products. But the green line, the lower concentration, came to an horizontal at after 7 seconds. But the pink line with a higher concentration came to horizontal at after 3 seconds. ये देखो वो तकरीबन 3 seconds पे हो गए थे, which means products are the same. Number of product is the same. The result is the same, but the reaction was faster. I got the product in a lesser time. Amount same the products की. This shows that an increased concentration of a solution, the rate of reaction will increase. Now, if we talk about the effect of increasing the temperature, again, आप देखो कि at a higher temperature, the graph has a steeper slope, and at a lower temperature, the graph is less steep. Compared to a reaction at lower temperature, the graph line for the same reaction, but at a higher temperature, has a steeper gradient at the start and becomes horizontal sooner. This shows that with an increased temperature, the rate of reaction will also increase. अब आप यहाँ पे भी देखो, the with a higher surface area, it has a steeper gradient, and with a lower surface area, again the slope is lesser. Product same है. Amount of the product is the same in both the reaction, only the speed is different. ठीक है. Product इसने भी 100 बनाए, इसने भी 100 बनाए. But the one with the higher surface area produced the products in 12 seconds, whereas the one with the lower surface area uh, produced the 100 products in 25 seconds. Compared to a reaction with lumps of the reactant, the graph line for the same reaction but with powdered reactant has a steeper gradient at the start and becomes horizontal sooner. This shows that with increased surface area, the rate of reaction will also increase. अब ये देखो, अगर आपके पास एक lump size के particles हो, this is a lump size particles. But when you have broken particles, बहुत finely हो, ठीक है, fine particles हो जाएं, they are going to have a larger surface area. Effect of a catalyst भी होता है, क्योंकि catalyst का काम क्या होता है? Catalyst always speeds up the reaction. Now here you can see the reactants being converted into products. ठीक है. Now when the reactants are being converted into product, what will happen? The energy needed to start the reaction without the catalyst was this much. But the moment when I added the catalyst, I only needed this much of energy. पहले आपको कितनी एनर्जी लग रही थी? 100. अब आपको कितनी एनर्जी लग रही है? 60 एनर्जी लग रही है, which means when you added the catalyst, less amount of energy is now needed to start the reaction. So catalyst basically आके activation energy decrease कर देता है. The energy needed to start a reaction is always decreased when you add a catalyst. So the diagram shows that when a catalyst is used, the activation energy is reduced as it creates an alternative pathway requiring lower activation energy. Lowering the activation energy means more particles will have enough energy to react when they come together. And this shows that when a catalyst is used, the rate of reaction will increase.